Previously, we did one examples of the curtailments of the reinforcement bar in continuous beam. Now let us try another example. We are using this simplified rules for the curtailment, which is based on figure 3.24 in British Standard at 110, only that it is presented in the graphical manner. Given the size of the cross-sections of the beam, 175 mm times 750 mm. The concrete cover is 25 mm. The largest aggregate size is 20 mm. And the size of the shielding is 8 mm. Let's say now you have done designing the beam. You will need at least 3 T16 as the top reinforcement bar at the interior support. And then you need 4 T12 as the bottom reinforcement bar at the mid-spec. Based on the amount of reinforcement bar given, we will try with these arrangements of the reinforcement. This is conditional to the minimum bar spacing is fulfilled. So what we're going to do here is first we need to check for the minimum bar spacing. You may use this formula to determine the minimum bar spacing. It is determined by the size of the reinforcement bar, the aggregate size plus 5 mm, and also at least 20 mm. You're going to choose the bigger value of the three. Let us first deal with the top reinforcement bar. You have the width of 175 minus the cover from both sides, 2 times 25, minus the size of the link, 2 times 8 mm, and then minus 3 times 16, which is the diameter of the bar size. The whole thing here is divided by 2 because you want to get the 2 spacing. Your actual spacing between the bar, it will be equals to 30.5. As for your minimum spacing, 16 mm rebar, 25 mm due to the aggregate past 5, and also 20 mm. The biggest value is 25 mm. That will give you 25 mm minimum spacing. Check against the actual spacing. Your actual spacing is greater than the minimum spacing. That means this arrangement of the reinforcement bar is acceptable. Now we're going to check for the bottom reinforcement. The minimum bar spacing is 25 mm, governed by the size of the aggregate. We're going to get the actual spacing of the bottom rebar. Take the width of the beam minus 2 times the cover minus 2 times the size of the link, and then minus 4 units of 12 mm diameter rebar. The whole thing here is divided by 3 due to 3 spacing between the 4 rebars. Your actual spacing is 20.3 mm. Compared with the minimum spacing, your actual spacing is not sufficient. That means this arrangement of the reinforcement bar is not acceptable. You cannot have 4 rebar here at the same effective depth from the beam. As a solution to this, you're going to move the reinforcement bar on top of the other reinforcement. Instead of having 4 reinforcement bar placed together, now you have staggered reinforcement. That will give you a bigger spacing in between the reinforcement bars. Let us check the actual spacing here. The width of the beam 175 minus 2 concrete cover minus 2 shielding size minus 2 unit of 12 mm rebar. There's only one spacing. That means the whole thing here is divided by 1. Now your actual spacing is 61 mm. This is greater than the minimum bar spacing required. Therefore, it is pass. With that, you will get the final layout of the bottom reinforcement bar for T12, something like this. And then top reinforcement bar of 3T16, something like this. Having the minimum spacing pass, that means you have no issue with the compactions of the concrete. And you have no issue with the bonding with the concrete. Next, we will look into how we're going to do the curtailment. By looking at the diagram here, the percentage here will indicate the minimum amount of reinforcement bar as compared to the reinforcement bar provided at the support and also at the mid-span. Let's say for the bottom reinforcement bar, you can do the curtailment at the locations of 0.1 times the effective length near to the end support with a minimum amount of 30% of the reinforcement as compared to this 40-12. You will do the same here, only the locations of the curtailment now is equal to 0.15 times the effective length. Based on the layout of the reinforcement, it is possible for you to reduce the amount of reinforcement. You can curtail the reinforcement here by removing the top two reinforcement bar here at these regions. That will give you 2T12 at the support. Something like this. To properly sketch this, it should look something like this. Here you will have double layer of reinforcement. Towards the support, you will have only one layer of reinforcement. At the mid-span, it will look something like this. Near to the support, it will look something like this. Now you need to determine where is the locations that you can have the curtailment. This side is 10% of your effective span. 7.5 meter, the 10% it will be equals to 750 mm. Make sure you round up to the nearest 25 mm. This is due to the considerations of the construction site, where the workers measure the dimensions using imperial units. 25 mm is equivalent to 1 inch. This allowed the easy conversions between the SI units and the imperial units. You will do the same from the other side. This time is 0.15 times effective length, which is equals to 1125 mm. That means you may stop your top reinforcement bar here. I mean these two reinforcement bar. Let's say now the calculated length here is not a round number or not rounded up to the nearest 25 mm. For example, 1130 mm. In order to make it rounded up to the nearest 25, you can choose to prolong the rebar here so that this length becomes slightly shorter. Instead of providing 1130, you can provide 1125. But you cannot make it shorter here. That means you cannot make it 1150 mm here. By making this shorter here, you will have issue not meeting the requirements of 100% of the bar areas here. You will need to make sure 100% is here and a minimum of 30%. The purpose of reducing the rebar for 4T12 to 2T12 here is that you at least need two bars, one at each corners of your shielding. That will give you 50%. In this case, the smallest bar diameter for the beam is 12 mm. It is nearly impossible for you to provide exactly 30%. What you can do now here is to provide 50%, which is slightly larger than this, through the curtailments of the two reinforcement bars stacking on top of them. You might want to ask, is it compulsory for you to do the curtailment? If you're not concerned with the amount of materials being wasted, actually it is okay for you to have this 40-12 continuous towards the end of the support. Just that you might need to consider one additional factor is that normally you don't like a lot of reinforcement bar near to the support, which will be the joint between the beams and the column. Imagine you have incoming beams here and you have a column also. There will be reinforcement bar from the incoming beam and there will be reinforcement bar from the column. If you choose with this same amount of reinforcement bar at the support here, you might have issue with the congestions of the reinforcement at the joint. In this case, it is not the more reinforcement bar, the better. When it is heavily reinforced at one place, congested, you might have issue with bonding with concrete due to poor quality of bond here. And when the reinforcement bar is not properly bonded with the concrete, the performance of the reinforced concrete members will be affected. Therefore, it is normally a good practice for you to do the curtailments in order to avoid the concentrations of the reinforcement bar at one place, especially at the joint. Next, we look at the top reinforcement. We need 3T16 as the top reinforcement at the interior support. Towards the end support here, you can reduce the bar to 2T16. Bare minimum, you need 2 units of rebar, one at each corners of the shell. Reducing from 3 units of rebar to 2 units of rebar, that gives you 66.7%. This is slightly higher than that 60% here. Therefore, you can choose to do the curtailment at this location. The provided amount of reinforcement bar is still greater than this 60%. As you cannot reduce the rebar further, we will stick to this 2T16 towards the end. Although the requirement here is only 20%, unless you reduce the bar size some more with a proper lapping, you may stick with 2T16 throughout the span. Now the next question here is, which bar to be curtailed? Initially, the arrangement is 3 units here. You will cut the one at the middle, leaving 2 bars at the corners. And where should this be in place? We are talking about 0.15 times the effective length, which is the same location here, 1125 mm. And make sure you check against this minimum of 45 times the bar diameter. This 45 times the bar diameter is referring to the bar size of 16 here. That gives you 720 mm. Comparing these two distance here, you choose the bigger one. Ultimately, you will have the curtailment done at 1.125 meters from the face of the internal support. Now you have the reinforcement bar being curtailed. Next, you might want to show the cross sections of the reinforcement. If you cut a section here, you will have 3T16 on the top and 2T12. That give you these arrangements of the reinforcement. If you cut the section here, you have 4T12, which is here, and 2T16, which is here. And if you cut the section here, it will be 2T12 here and 2T16 here. You will see different arrangements of the reinforcement bar at different locations.